right, good morning everyone. Hope you are all doing well today. So today I'd like to start off with some quick announcements. I'm going to get started grading the first homework assignments today, hopefully. That's the plan anyway, and I'm hoping to have the first homework assignment finished graded, but be done with grading that assignment by the end of this week. So hopefully you should get your grade back for that in the next few days. Assignment 2, as I'm sure you're aware, is due today. I can see that a lot of you are today, which is great. If not, you still have time. I'm not going to be able to even start grading assignment 2 until probably next week. I don't think I'm going to even be able to look at it until early next week. So definitely let me know if you need any help, and also remember that we have office hours available, TA office hours available. The hours and locations are on Canvas if you need to get some help. I'm also happy to meet you or email or whatever you need. As far as today goes, we're actually going to spend a bit of time talking about the next assignment. This is actually, I'd say, probably one of the trickier, if not the trickiest, of the 5 assignments that I'm going to give to you prior to the project. You may have noticed you also get an additional week to work on this one, so you actually have 2 weeks to do this one, not 1 week, so that gives you a little bit of breathing room for the next couple of weeks. But it is a little bit tricky, and I actually need to kind of finish setting it up, and I'm going to walk you through it all today. So let's dive in and explain a little bit about what's going on, and we'll review some Git concepts in the process. For assignment 2, you wrote a little script that was supposed to do some grading. Those files were just given to you, and then you graded them, right? But that's actually not how grading actually works in practice. As you probably know, a lot of times for science projects especially, we ask you to make a repository. You have to commit your work to that repository, and then the work that you submit, commit and push to your repository is what actually gets graded. That's the way that it works for a lot of classes, and kind of including this class. So for this assignment, for assignment 3, you're going to be tasked to write a script, another bash script. So similar to assignment 2 in some ways, but then you're going to be asked to write one that actually, clones the repository, navigates to the proper place in the repository where the code is supposed to be. In this example, we actually also have some Java code, so I'm actually going to show you how to run Java code on the command line today. That's another important skill I think you should be able to know. And then, verify that the results are correct, and give the student the grade that they earned on the assignment. So we are going to be using GitHub Classroom for this. There's a link here to create your repository for you if you've taken 131 or basically any other computer science class, 247. You're familiar with how this process works. But the expectations, I think, in this class for how you use your repository are a little bit higher. So I want you to be a little bit careful about how you use your repository, and pay attention to what the actual expectations are, especially when it comes to turning in your work, which we'll talk about a little bit later on. There's going to be a lot of files in the repository. Some of these, they should all be somewhat self-explanatory, but here are the fake students for this particular assignment in that particular file. As I mentioned before, they're going to be running a Java program. It's a simple Caesar cipher. The actual Java code is not important, really, for the purposes of this assignment. But the Java code needs to produce some output. And so the expected output is what constitutes a correct answer, right? If your Java code produces this output, then you know it is correct. And then this is the expected grade. So I'm telling you what each student should get. In this assignment, it's actually even simpler. It's just a 1 if they did everything correctly, and a 0 if they didn't. So if they mess up anything at any point in time, you can just give them a 0 and move on to the next. A little bit heavy-handed, but that's okay. Just trying to keep things simple. I'm expecting you to use branches on your repository. So unlike probably every other class that you've used GitHub repositories in, I do not want you to commit and push your work to the master branch, the main branch. I want you to create a new branch for the work that you're going to do, and then write your script in that branch. Here is the way that this command is going to be, your script is going to be executed when when I go to grade this assignment after you submit it, it's a bit of a long one. I kind of actually don't like how long this command is, but I think it's important to understand what all these pieces are and why they exist. These first three here, these are arguments. We talked about arguments. We also talked about how to access arguments from within your script, so that's going to be important information. The first one is the name of the Java program that we're trying to run. So we're trying to run a program called Cypher. I'm actually going to run that Java program for you in just a few minutes to show you all the commands that you need to run that Java program. This is the file that contains what we expect the output from the Java program to be. And then this is the name of the file where we expect the student's output to be. After the Java program is run, we expect it to create a file called output.txt. And so essentially we're comparing the student's output against whatever is in this expected output file. We'll feed in the student keys. That's actually just like we did for assignment 2, so that shouldn't really be any different to feed those in by redirect. But I do want to point out, right, these are arguments and I expect them to be used appropriately. One of the more common things that I count off for on this assignment is people hard coding the file names into their script. Please don't do that. There really should not be a need to hard code in file names into your script. That's actually a bad thing, because if I try to run that script somewhere, somewhere else where those files don't exist, then it's going to break. I want it to be able to be very flexible, very general. So use the arguments as they're provided to you. Don't ignore them and just hard code those file names in your script. Please, 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 please don't do that. And if you're confused about what I'm asking you to do, come talk to me about it, and I'll give you some more explanation. I'll help clarify that for you. All right, your script needs to do the following things. So you need to clone the repositories. I'm actually going to do that for one or two of these repositories right now. I actually made fake repositories for a bunch of celebrities, or not real people, some of them, right? So here are all the fake repositories that I created this morning, and these are fake students that I'm asking you to grade, right? And so let's take a look at, there's a couple of these in particular that I would like to take a look at. Let's just start with Beyonce. I believe Beyonce is one of the students who did it properly. Beyonce knows what's going on. So I want to clone Beyonce's repository. Now I'm doing this on the command line, right? But you're going to have to think about how to incorporate this into your script. Uh-oh. Server certificate bound. That's not good. That's bizarre. Let me see if I can't figure out why that's the case. I've never seen that error before in my life, but let's see if Google has seen it before. I imagine perhaps it has. Computer doesn't trust the certificate. Okay. I do trust it though. I don't understand. This has major security implications. Well, that should be really safe to copy paste into my command line then. That was a joke. Okay. I kind of know what that's telling me, so I wasn't too worried about it, and honestly, it'll be okay. Sorry for that little sidetrack there. Just wanted to make sure that I got things up and running. All right, cool. So if we clone Beyonce's repository, we'll see that there's actually nothing in here except for a description of the assignment that Beyonce was supposed to complete. That's not what we're looking for. We're looking for the work that Beyonce has supposedly done. I'm telling you that Beyonce did it. She did it properly, but it's not here. It's actually in a different branch. It's in a different branch called Cypher. How do I move branches again? What's the command? How do I move from the branch I'm currently on to a different one? Checkout. Git checkout. Cypher is the command to switch to the Cipher branch, which is where the students in this particular class were told to put their work. And now if I run ls, you can see, oh, hey, magically Cipher.java has appeared. That's Beyonce's submission. That's the submission that she made, right? And that's her work. Okay, cool. So that's your first task. For every repository, you need to check, you need to clone the repository, you need to switch it over to the branch. And now, I'm going to come back to this point a little bit later. You need to, run the Java code and check the output. So I'm not going to talk about the checking the output part. I'm going to leave that for you. But let's talk a little bit about running the Java code part, because that is not something we've talked about too much. We write code in Java. That's a nice human readable-ish thing, right? But the computer doesn't run it that way. The computer wants ones and zeros. The computer wants binary. So actually, whenever you click the the Go button in Eclipse or Visual Studio Code or whatever way you're used to running code, it's actually taking your code that you wrote and turning it into ones and zeros, and then running it and doing all of that when you click that button. We can do it as well in the command line, but we actually have to do all of those steps. We have to do what's called compiling the code. That's what takes it from Java code and turns it into ones and zeros. Then we actually have to run the program, run the ones and zeros that got generated for the computer to actually run the program. So in order to do that, actually, believe it or not, the first thing is to make sure we have Java installed. And if you are on a Mac and you just type Java and hit enter, you'll probably see something like this, which is, it might look a little bit different, but it should, look something like this. Or you can type Java -- version. And I would expect it to work. It'll say, I've got Java version so-and-so. Your version might be different than mine. That doesn't matter. If you're on a PC, like me, you're on a Windows machine, and you try this on the Windows subsystem for Linux, I would expect it to say, I have no idea what you're talking about. Even if you've already installed Java on your computer, it's not going to know where to find it. So we actually need to kind of reinstall Java on this command line in order for you to be able to use it effectively. And I think that even if you're on a Mac and you don't have to do this, there's still some stuff to be learned here, some important concepts, some important commands. Specifically, a lot of Linux distributions keep things like Java on their own repositories. So if I'm running a system like this, there's actually a repository of all the programs that can be run on this command line. Apple doesn't really do that. Some other Apple associated entities do, and Homebrew is kind of an example of Apple community members trying to replicate this idea of public packages. But in order to install Java on the command line, we have to use what's called a package manager, and the one that's by far the most common that you've heard of, if you've done anything with this at all, is called apt. And so the first thing that you want to do, if you're on a PC, if you're on a Mac, again, you probably don't have to do this. But if you're on a PC and you need to install Java, first thing to do is to run apt update, and it's going to probably tell you that permission is denied, just like it told me, because installing stuff on a computer is considered a potentially risky thing, potentially dangerous thing, can change stuff. So we actually need to run it as an administrator, which means we need to use sudo. This is a very important command for everyone to be aware of, but it comes with great power, comes with great responsibility, right? When you run something with sudo, the whole point of this command is to kind of make you stop and think, be like, hey, what I'm about to do is potentially dangerous, potentially destructive. Am I sure it's okay to do? Am I sure it's not going to mess anything up? You also need a password, right? So if I try to do something that I don't have the ability to do, then it's going to tell me to go away. So it's going to ask me for my password, which is just your Windows password or your Mac password, respectively. And now it's going to say, oh, look at all of these outdated programs. I haven't run update in a very long time, apparently. There's so much stuff. That's okay. We'll go ahead and tell it to Yours probably won't have this much stuff. I would be very surprised if it did. But once this is done downloading, installing, I'll show you how to actually get Java installed. Uh-oh. Looks like there were a few things that didn't work for whatever reason, but I'm going to see if I can move on to the next step. And the command for installing Java is going to look something like this. It's going to be, what is it called? It's called, hang on, I might have to Google it actually. Apt install open JDK. Oh, it's already purple. I've already tried to do this before. Go figure. Here we go. This is what I'm looking for. Something like this. Open JDK-17-JDK. Yeah, and so this is going to install Java version 17. I guess they're probably on version 20 something by now. It doesn't really matter. Not for this class anyway. But it's downloading and installing Java now on my Windows machine. If you have problems with this, if you got stuck somewhere along the way, I am recording, so you can also come back and watch this later. But also, I would be happy to chat with you and make sure that everything's up and running before you leave here today. Now that that little side detour is out of the way, we can get back to the task at hand, which is compiling, running Java. These next commands are commands that you're going to need for the upcoming homework assignment. Actually, to compile Java, it's a slightly different command. Java C, so C for compiler, is what's going to take the Java code and turn it into ones and zeros. All we have to do is feed in the Java file that we're interested in. So if I say Java C cipher.java, that's going to tell it to take the existing Java code and turn it into ones and zeros. And now if I run ls, you'll see that actually we have not just cipher.java, but we have a new file. That's the result of the command that I just ran. This is binary. If you open that file up and try to look at it, you won't be able to understand a thing. It's not meant for you. It's meant for the computer. This is stuff for the computer to run to make the code work. So in order to do that, we'll say Java cipher. Notice I didn't say cipher.class. I didn't say cipher.java. I'm not telling it the name of a file here. I'm telling it the name of a program. The name of the program is the, the capital C without the dot stuff after it. And once we do that, it may look like nothing happened, but if we run ls one more time, we'll see that after we ran that Java code, we got output.txt. And so your task then is to compare this output against what we expect the output to be in the expected output file, and if they're the same, which in this case I know they are, because I made these files, we would give Beyonce the credit and say, good job, Beyonce. Probably not as exciting as winning a bunch of Grammys, but she's doing good. I would like to take a moment actually and make sure that everybody can do this before. I think it's very important, right? I'd like to take a few minutes, and if you haven't actually tried to run the Java C and the Java commands to compile and run the code, I would actually like for you to take a few minutes and do it, even if you need to open up a quick hello file in Java, right, and do a quick hello world. You don't need to run it on one of the homework ones necessarily, but you could very quickly just open up, put in a main method, something like this. And then the closing curly brackets. Like, this is the absolute bare minimum Java program you could expect. So take a few minutes and just dump that into a file and run it through Java C and Java, and just make sure that those commands are operating properly on your computer. I'm going to come around if you're stuck on installing Java, if you're stuck on running Java. I want to help you. So for the next 5-10 10 minutes or so. I'll be around. Let me know what you're stuck on, and then we'll get back on to our next topic. I can put the Hello World back up again too. That would be, I mean, it's very simple. So there's the code that I wrote, and then the commands that I used to compile and run it are directly above. In a few minutes, make sure you can do that on your machine. Let me know if you get stuck. Meanwhile. If you're on a Mac, do you wanna? Yeah, you are. You should be okay. Oh well. Okay, you may have to do what it says then and go to Java and download the JDK. That's what it's called. Yeah, just download the JDK and then try it again. Yeah. What's up? Okay. Yeah, that's interesting. Can you try just to, let me see. There's like a default password. It doesn't have a password. It looks like, try it and just hit enter without putting a password in to see if there actually is something. Alright. Sounds like it. All right, great. So let's return back to, we're actually not done talking about assignment 3, believe it or not. I've got some more things that I want to chat with you about, specifically the timing of the issue, which is that, you know, due dates. I know I'm kind of flexible with the due dates in this class especially, but that's not always true. Sometimes I have to actually enforce a hard deadline on things, and I'm asking you to enforce a hard deadline on this assignment. So if a student has turned in an assignment for this particular assignment, it was due at 10 o'clock today, 10 o'clock this morning. Which means that in order for you to check to see if the student has done their work properly, you need to know what their repository looked like at 10 o'clock this morning. You might be thinking, well, it looks like whatever it looks like right now, which is true, except, I mean, you know, I'm going to come in here right this second and grab one of our nice students here, this guy, Lewis Cole, and clone his repo, and then I'm going to, you know, switch over to the Cypher branch and have him turn in his assignment right now. So it's, you know, he's a little late. He's 28 minutes late, but there we go. Just need to copy in the copy of the code, which I know I have. Oh, I need to put it here in this repository. There we go. So I'm on the proper branch. Let me make sure I'm on the proper branch. Yeah, I'm on the Cypher branch. I'm pretending to be Lewis Cole right now. I'm turning in my homework. That's basically what's happening. On the proper branch, I put the file in there. I'm going to add the file. Sure, that's fine. I'm going to commit the file. Hope it's not too late. Well, actually it is though, right? And then I'm gonna push the file. So if I go check out this repo, 2 seconds ago, nice. If I go check out the repository on GitHub, we'll see that yesterday, of course, I'm gonna have to, my clock is off. Why is my clock off on Bash? That makes me, why does it think this happened yesterday? Thinks it happened at February 4th at 3:58 a.m. Central Standard Time. I'm gonna have to fix this after class. I'm gonna go in and submit one of these after class for one of these students and make sure that the timestamp is correct. There's something funky with my computer time. This student is gonna submit the assignment late. So when you look at what his repository looks like at 10 o'clock this morning, that file's not gonna be there. And not only that, I'm going to do something even slightly worse / mean. Don't get too mad at me for what I'm about to do. I'm going to go into, where did that Beyonce one go? I forget where I put it. Oh, my computer's so messy. There it is. I'm going to go into poor Beyonce's repository, and I'm going to delete her very good, very much working work. I'm going to get rid of these extra junk files too, or these extra files that were created as well. And I'm also going to, you know, actually this is a good thing to talk about. How do we remove a file from Git, right? How do we actually tell Git to remove a file? Because we can see, oh, it has been deleted, right? But how do I actually tell Git that I want it to remain deleted? You still have to add cipher.java, right? It seems a little silly to have to do, but I deleted the file. I still have to add it to Git to say, hey, yes, I want you to track the fact that this file has been deleted. And now we can commit. Where did my homework go? And push. And I think Beyonce is going to have the same problem with my computer clock that this person did. I'm going to fix all this after class to make it look properly as soon as class is over. But the point I'm trying to make is there's one student who turned in their work too late. I want you to catch that. I want you to catch that it came in after the deadline. I want you to look at their repository as it happened at that particular time. And then for poor Beyonce, I want you to do the same thing. She was right. She had the homework in on time. It was there. And then something happened. It got deleted, but after the deadline, well, that's okay. It's after the deadline that it got deleted. I want you to be able to still give her the grade that she did, that she earned, because the work was there. It was on time. So that's, I think, probably one of the trickiest parts of this entire assignment. I intentionally leave it kind of open-ended to say, you know, you're going to have to Google this. You're going to have to search around. You're going to have to read Stack Overflow posts. You're going to have to, you can try and ask ChatGPT, but it's probably reading from Stack Overflow posts too. So, you know, eventually you're getting back there, right? Do what you can. See if you can figure out this problem so that you can use it in your script. And then let's talk about submission. To submit this, so you're being asked to create a branch. To submit it, I want you to submit a pull request for the branch that you've created. We actually haven't talked about that. Yeah, we haven't talked about what pull requests are, but that's on our agenda for today. So let's talk about it. What is a pull request? A pull request is really just a fancy way for people to talk about whether they should perform a merge or not. So recall from class on Monday that we merge branches into other branches. So the way that it typically works is I'm going to have, you know, one branch that is my master branch. That's where stuff goes when I know for a fact that it's working. And everybody on my team basically agrees that, yeah, the stuff that's in the master branch is all code that's good and it works. If it's on a different branch, if it's not on the master branch, typically that means that it is a work in progress. So I'm working on it, somebody else is working on it, right? And when I'm done with my work in progress, instead of me going in and directly merging my finished code into the master branch to say that I'm done, right? I'm actually, if I'm working on a team, that's considered a little rude. I want to get their input first. In fact, I'm required to, right? My boss is going to make me. My boss needs to sign off. So instead of doing the merge myself, I'm going to create what's called a pull request, which is really just a flag to everybody on the team, everybody on the repository to say, hey, somebody's got some new stuff they want to merge into probably the master branch. But, you know, somebody's got some new stuff that they want you to look at and give your opinions on, give your feedback on, give your approval for. Now, we can use pull requests in a lot of different situations. If I'm working on a project by myself, I'm never using a pull request on those kinds of projects. It's silly. It's not for that purpose. I'm just going to do the merge, just like you saw me do in class the other day. Pull requests are really for when you're working with groups of people, when you want other people to be able to see and comment on the work that you've done in a particular branch, and then hopefully accept that work as, you know, worthy of being included with all the other stuff on the master branch. That's what pull requests are really for. But I want to walk you through this process, show you how pull requests work so that you know a little bit about them and what to expect on the homework assignment in terms of how to turn it in. So in order to do that, I'm actually going to chat with you about one other thing really quickly, which is contributing to repositories. From Monday's class, I made this repository right here, Git Practice 2025, and I made those files and force a conflict, right? You don't need me to redo everything that I did on Monday, that's not a problem. But the point I'm trying to make here is this is my repository. I created this. And if I wanted to, I could give you access to it. All of you, if I wanted to, could give you access to it. I have to go in and add you all individually one at a time. I don't really want to do that. But if I'm working with you on a team, then that's going to happen, right? That's how teams work. Every team member is going to have access to the repository. And that's one way that you're going to get practice doing pull requests, especially on the project. But today, since I don't really want to take the time to add each of you to this team, we're going to do it a little bit differently. talk to you about how you can contribute to a project even if you're not already a member of that team. So this is a common thing, especially among open source projects. There's a lot of projects where you can see all the code out on GitHub, and maybe you really love a program that somebody wrote and you have some ideas on how to improve it, but you're not part of that development community, right? You don't work on that team. They don't even know who you are. You're just a person. Well, what you can do is you can actually take their code. It's open source, right? That means you can see it all. So you can actually take their code and make your own copy of it. That's called a fork. It's called making a fork. And once you've made your fork, that's your copy. It's my code. That's where it came from, but it's your copy of that code. So now you can manipulate that copy and all you want without, the original owners being concerned about conflicts or anything like that. And then once you've added this brand new thing that you think's awesome and is going to knock everybody's socks off, you can submit a pull request back to the original repository and say, hey, look, I made a fork of your stuff and added this new thing. Take a look at it, see if maybe it's something you want to incorporate into your project. That's something that I would like for you all to get ready to do right now. Do for me right now. So we're going to stop and do a quick little exercise. I've been talking a lot today. Would like for you to get some practice doing some Git stuff. So I need to figure out where... Look at how messy my computer is. I need to clean this stuff up. There is so much junk in here. Oh my gosh. I'm a little bit embarrassed. But that's okay. Wow, this is even messier. It's in here. It's all organized in my head, I promise. Alright, the exercise that I want you to do is right here. I found it. Here is the GitHub URL to that repository that I was just talking about. I want you to go make a fork of it on github.com. And the way to do that is to follow that link. And then, I don't know if I'll see it because, oh yeah, it is here. There's a button right at the top. It says fork. Click that button to make a fork of this repository. It's at 0 now. It should be at, I don't know, 20 something, 30 something, hopefully by the time this is done. Once you make a fork, I want you to clone your fork, right? Don't clone this, clone your copy. And then create a new file, add it, commit it, and push it. Honestly, I skipped a step. It should be create a branch, right? Add your file, commit it, and push it. There we go. Yeah, so create a branch, create a new file, add it to the repository, commit it, and push it. And then once you've done that, once you've added that new file to your fork, when you go to the web page for your repository, it'll prompt you to make a pull request. I want you to make a pull request back to my repository and say, hey, Professor Shook, look at this file I added. You can put whatever you want in the file, just say hello or something, right? Make sure you make your own. Well, yeah, I'll let you experiment. You can make mistakes. That's kind of what this stuff is for. I'm going to shut up now and let you all get started on this exercise. Let me know if you need any help or if you get stuck along the way. Let's see what we got here. Good number of forks. Let's see, 2 pull requests. All right, we're getting there. Yes.
I cannot put it in GitHub.
Okay, so that's a personal access.
So do I need so for one of my other classes I do need an SSH key to use GitHub with my thing. So do I need that same key?
I mean, you can set it up that way. It'll work for this class too, if that's how you want to set it up for this class. But it's really just a personal access token, which is generated through GitHub, the website. You have to. It's a big long string of letters. I mean, GitHub requires you to use it. It's not your GitHub password. It's enforced by the website, github.com.
So is it just if my access tokens somewhere?
Well, it won't show it to you again.
Oh, it
So
was that one.
you have to make a new one. If you need it now, you have to make a new one.
Okay.
And there is a way to have Git remember it, so you're not typing it in over and over and over again. I don't remember that hand off the top of my head. A little bit of Googling might get you to
Okay,
the
so
solution for that. But you're going to need a new personal access token to use this. And you can generate that in the settings on the GitHub website. Let me know if you need more help with that.
That would be my way. And it's the one.
There we go. That's looking a bit better. Just a couple more minutes. I do have a few more things I want to chat with you about today. I'll give you a couple more minutes. All right. Yeah, if you got stuck along the way, that's very understandable. I know Git can be tricky sometimes. Please let me know if you run into any problems so we can make sure you're set up and ready to go for assignment 3. But it looks like at least a good number of you were successful in submitting the pull requests. So I want to show you what these actually look like, right? Here is the list of all the pull requests that got sent to me. And from my perspective, actually from your perspective as well, right? It just is a place for other people, especially other people who are involved in the repository, to leave comments. So we can say, hey, yeah, this is great. Or hey, you need to fix this up, right? I noticed there's a mistake here, so why don't you go fix this up? And then once you comment about the changes, once everybody agrees that everything is ready to go and sufficient to be merged into whatever it's being merged into, you can actually do the merge right through here. So this circumvents the need to even do the git merge branch name command. You actually don't even need to do that part. GitHub will do it all for you by clicking this button. And if you're working on a team project, this is probably how your merges are going to go. This is a very well developed process. If you go outside of it, a lot of times it'll be considered rude at best, perhaps, or an offense at worst, because they don't want rogue people just sticking whatever they want in the code before somebody else has a chance to look at it, verify it, peer review it, which we're going to be doing in this class, and make sure everything's ready and actually in tip-top shape. So for the assignment, I'm going to point out that this is a little bit different than the way you did the pull request here is a little bit different than how I'm asking you to do for the assignment. For the assignment, the pull request will be not on my repository, but on your repository, right? So that's okay. Anytime we have a branch that we wish to merge, pull requests can be used to accomplish that. And that's what I want you to get used to doing for assignment 3. Any questions about the exercise or anything I'm done finally talking to you about assignment 3 for now at least. But I do have a few loose ends that I want to wrap up with the 25-ish minutes that we have today. Any questions before I forge ahead? Move on with the next. Okay, cool. Then let's talk about some other stuff that, some of which may honestly still be useful to you on the assignment, but isn't necessarily directly related to the assignment. One thing I want to chat with you about is what goes into a repository. This is going to become particularly important when you work on the project. We work on the project with at least 2 or 3 other people, and if you put something in the repository that's not supposed to be there, it could really affect somebody else, because it could you're actually sending files right to another person's computer. So it's considered bad form to put anything into a repository that is specific to your laptop. The only stuff that should go into a repository is stuff that can be used on other people's computers as well as your own computer. So that might be a little bit confusing, but let me explain a bit more about what I mean and some examples of what I wouldn't put into a repository. The classic example of what not to put into a repository are settings files. So if you use Eclipse or any IDE, VS Code even, sometimes those settings files get saved in your directory, and if you put them in the repository, the next time your colleague opens that repository, then their font's going to be purple and their background's going to be bright pink, and it's going to look the way that you like to have your settings, but probably not the way that they like to have their settings on their machine. So it's kind of a classic funny prank that people pull on each other sometimes, but not a nice thing to do. Not a good thing to include any kind of personal settings files in a repository, especially if they relate to your own coding style preferences, right? Those should be consistent for everybody across the entire repository. Any stuff that's specific to just you, you keep it to yourself. You keep it on your computer. It does not hit the repository. Another very, very, very important example of stuff that is unique to your computer and should never go in the repository. I think I deleted most of the files from earlier, but we did the example of compiling Java code. I was in, oh well, I'll do it right now. So after we compile a piece of Java code, it generates this class file. And as I told you before, right, if I actually open up this class file and try to look at it, I mean, this isn't for me. This is not intended for me. This is meant for the computer to run, and more specifically, it is meant for my computer to run, not even your computer. It's meant for my computer to run. So this binary code is often specific to the machine where it was created on. It should not go in the repository. If I gave this file to you and said, hey, you should run this, it wouldn't work. I suppose there's a chance that it would, but a much, 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 much bigger chance that it wouldn't. You would have to have very similar setup to what I have, right, in order for this file to work on your computer. So we put the Java code into the repository. We don't put the compiled Java code, and that goes for any language that you're working with. In practice, actually, if you've used Eclipse a lot or any other IDEs, you'll see that they keep those files separately. A lot of times there's an SRC folder for source, right? That's the file we want in the repository. But then there's another folder called bin, short for binary, which is where all of the class files go. And if you open up some of your Eclipse projects, either on the command line or go through your file browser, you'll see that they all follow that format where all the bin goes into, all the class files go into the bin folder. That bin folder should never, ever, 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 ever hit your repository, ever. Should never be a class file in your repository, ever, 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 ever. And definitely something that will come into play when we do the project later on this semester. So in order to kind of protect us from making those mistakes, because it's one thing to be able to remember, it's another thing to, have a system to help prevent those kinds of mistakes from happening. You can do what's called a git ignore. You can use what's called the git ignore file. So if I go to, every time you create a new repository on GitHub, it's going to give you an option to add a git ignore file. And they're usually specific to the language that you're working on. You can make your own, you're not limited to what's provided here. If you really want to make your own git ignore file, you can, and you can tailor it to whatever you want, right? But a lot of times what's provided to us from GitHub are good, and so we're using Java a lot in this class. If I make one with Java, I'm just doing this to see what the git ignore looks like. I don't really care about any of this other stuff right now. So what do we see? Oh, look, it's saying right at the very top, it's saying no class files. So these are a list of things for Git to ignore. If it shows up in this file and you try to add it to the repository, it's going to say nope. Right? So if it's in this file, so right at the top of the list, class files, we're going to ignore those. Those never get added to our repository. Log files never get added. Jar files never get added, right? So these are just a list of common things that people who do Java development will often see that we don't want in our repository. So you can use this git ignore file to just automatically exclude anything like that. Prevent any issues like that from occurring. I want to talk to you about something else. Actually, this is kind of related to assignment 3 in that could be a useful way for you to think about that time problem, checking out the repository at a given time. Recall that all commits are logged. I want to get back actually to that repository. Where is that Git practice repository that I had? My goodness. Okay. Oh, okay. I see. Recall from the log, right? It shows us a list of commits. Well, these are checkpoints. These are snapshots. And if we want to, we can actually go back in time and look at the repository as it existed at one of these snapshots, at any one of these snapshots. There's only 2 for us to choose from here, right? But it's possible for us to pick any of them that we would like to go back to. And the way to do that is to first take a look at this thing right here. I know it looks like a long bunch of gibberish. That's a number, actually. It's a unique number. It's a commit number. Every commit you make gets assigned a number to it. A unique number just to recognize every commit as its own unique individual entity. We don't need this whole thing. We actually just need the first few digits. So let's say that this is a snapshot in the past that I would like to go take a look at. The way that I can do that is I can say git checkout. We've seen that command before. That's the command we've been using to switch from branch to branch. It's also the command that we use to switch from commit to commit. So I can actually use this to go back in time by just typing in the first few digits of that commit number. You don't need a whole bunch of them. And so it's going to say, all right, we are now at the commit with this number. Here's the commit message. It matches the commit message. It's telling us that we are now looking at this specific snapshot as the repository looked at that particular moment in time. And you'll notice that actually the only real change is that that cipher.java file is gone now, because that didn't get added until later. So this commit didn't have it, so that file is gone now. And if we want to go back to where we were before, if we want to go back to the repository as it exists in the current moment, we can just check out the branch again. And then we'll see that the branch has been restored to what the branch currently is. So this hopping around of commit to commit is another very useful thing. Consider the case where it doesn't happen. It hopefully doesn't happen very often with peer review, but it certainly does happen. I mean, it does happen often all the time. Humans make mistakes, right? Stuff's going to slip through. I thought this was good code. My friends, my colleagues thought it was good code. We let it in, but then, uh-oh, big major bug, big major problem. Like, you got 2 options. You can go in and try to fix the bug by adding more stuff to it, or you can actually roll back the whole commit and be like, hey, whoops, this snapshot's not good. Let's roll it back to the previous snapshot and start over, try again from there, right? So those are both options for you, available to you for taking a look. And even cooler, I think, I wish I had a different repository to practice on, actually, than this one. I don't know where my repository went to for... That's okay. I was going to show you that you can actually see the differences between the different commits as well. You can also do that through GitHub, which I think is a nice thing to know how to do. If you click on any repository and go to where is that? Here, this is the one I want. I want to clone this one real quick. If you click on this little clock right here, it actually shows you a list of all the commits that exist, and you can see all the files that have been changed and all the differences and stuff like that. But I'm just gonna clone this real quick and cd into it. Uh-oh. 2025. There we go. All right. So if I go in here and I'm just going to make a random change, not too random, but yeah. Oh, I forgot to add it. Whoops. My bad. I want to type that command again, so I'll use the up arrow to do it. All right, so now if I look at the log, right, the bottom commit is how it looked when I first cloned it. The top commit is the one that I just made. And I might be wondering, what's the difference? What's the difference between how it looks now and how it used to look at this moment in time? You can actually use, this is one of my favorite commands. Git diff is a great command. It shows you the difference in the repository between what it looks like right now against any commit just by typing in the commit number. So 8DBE is what I'm seeing as the first few digits here. Whoops. I used it wrong. Unknown revision, or do I need more digits? Oh, it's 8BD. I got the letters flipped. There we go. Yeah, awesome. So it's showing me the difference, where the differences are, right? It's saying that here's what it looks like now, and here's what it used to look like at that previous commit. So I can actually see all the changes. And if there are changes across multiple files, it will show me all those changes across multiple files. Really, really powerful, really, really interesting tool to kind of look back in time and see how changes have been implemented on the repository over time. Cool. I'm trying to think what else I need to chat with you about. Oh yeah, let's talk about I think I just have one more little tidbit for you before I'm gonna let you get out of here for today, and it actually has to do more with scripting, the scripting piece, since that is a part of the assignment as well. I wanted to talk to you about debugging. So if I go into one of these loop examples, these loop script examples that we did the other day, for example, I want to show you what happens when we try and do some debugging on this, because it might seem a little interesting to think about what debugging even is with a script. But if you say set -x within one of your bash scripts, you're telling it that you actually want to start debug mode. And then you have to also remember to set +x at the end, so you can kind of fence post in your code a little bit, right? You're using the set -x and set +x to indicate what part of the script you're interested in trying to debug or trying to learn more about. This is a small example, so I just did the whole thing. But now notice that once you run it with those in, it actually shows you every single step along the way, right? The exact commands that are being executed. So here it's saying echo 6, and then there's the result of that command. Echo 7, there's the result of that command. So it's doing a much more verbose explanation of the commands that are being run and exactly what's happening. You can see that I'm in that loop for a little while. So maybe not the best example of showing what this particular flag is capable of, but it is useful. And if you get stuck on the assignment, I would encourage you to try sectioning in the part of the script that you are confused about with this command and see if that can help you solve some of your problems. All right. I think I covered everything that you all need for assignment 3. I really, before you leave today, I know we have a few minutes left, so if you are in a situation where you can't get Java working on the command line, I really hope you stick around and talk to me so that I can make sure that that's up and running for you. If you're having Git problems, right, committing and pushing stuff via command line, I know some people needed personal access token help button and stuff like that. I hope you stick around for the last few minutes and let me help you with that so that you're all up and running, because you will need to have all that stuff functioning in order to be able to do this next assignment, right? So let me know if you need help with that stuff. Otherwise, have a good rest of your week. We're going to start a totally new topic next week. No more good stuff, a little bit less command line stuff, but so interesting. Can't wait to talk to you about it then. I'll see you on Monday. I'll be right with you. Just a second.